Hello, everybody. Here we are, 5.2 common factors. Just have one small bit of notes for you here, and then we'll get started. So, greatest common factor is the largest factor that all numbers share. I feel like this comes up quite a bit in fractions. I think the textbook also is maybe going to ask you for lowest common multiple. Um, and maybe I'll just go over that quickly. For example, if we have, 2 and 6, the lowest number that both of these go into, we got 2, 4, 6, 6, lowest common multiple, there you go, is going to be 6. So the lowest one that both of them go into. And the greatest common factor, we'll spend more time, certainly, or really the bulk of this lesson on looking at the greatest common factor. So let's do it. I have some examples here. These ones might be pretty rudimentary for you, but I think it's good to get in the habit of doing it. So for 12, 16, and 40, I'm just going to list all of the factors or all of the numbers that divide evenly into 12. So 1 goes into 12, 2 goes into 12, 3 goes into 12, 4, 6, and 12. For 16, the numbers that divide evenly into 16, that's 1. 2 goes in there because it's even. 3 doesn't. 4 goes in there. 8 goes in there. And 16 goes in there. And for 40, 1 goes in there. 2 goes in there. It's even. 4 goes in there. 5 goes in there. Not 6, not 7. 8 goes in there. 8 times 5. And then that looks like we got 4 times 10, 2 times 20, and 1 times 40. And now we're looking for the greatest one, not the best, but the biggest one, the biggest number that goes into each of these. Looks like 4, 4, 4. So the greatest common factor of 12, 16, and 40 is 4. Okay, let's do these next ones. Let's do 12, 21, and 36. So we already did 12. That was 1. 2 goes in there. 3, 4, 6, and 12. 21, 1 goes in there. 3 goes in there. 7, and 21. And 36, we got a good number. We got 1, 2 goes in there. It's even. 3 goes in there. 4 goes in there. 5 doesn't go in. 6 goes in there. 6 times 6. And then 9. 4 times 9 is 36. 3 times 13. No, not 13. 12. 3 times 12 is 36. 2 times 18 is 36. And then 1 times 36 is 36. And now for the greatest common factor, we're looking for the biggest number that goes into each of these. Looks like it's going to be 3. So the greatest common factor for 12, 21, and 36 is 3. Okay. Now let's look at some variables. So what are the factors of x cubed, x squared, and x to the 4? So what are the things that divide evenly into these monomials? And you'll see, I mean, it's less complicated than you think. So x divides evenly into there. X squared can go evenly into there. And x cubed can go evenly into there. For x squared, x can go into there, and x squared can go into there. And x to the 4, you guessed it, x can go in there, x squared, x to the 3, and x to the 4. And what is the biggest, the greatest of all of these? Looks like x squared. So the greatest common factor of these 3 is x squared. Okay, let's look at the next one. So we have an x and a y. So we can list the variables kind of in a similar way. Let's list all of the x's. So x, x squared, and x cubed, and just a single y. Here, x can go in there, x squared, Y can go in there, and y squared. And for this one, x, just x on its own, and x squared, and y squared, and y to the 3. And now we're going to look for the biggest x and the biggest y. So looks like they all have an x squared. And looks like they all at least have a y. So the greatest common factor for these monomials is x squared y. So this is the biggest factor that you could pull out of each of these. Okay, the biggest one that you could pull out of each of those. And why is this important? Well, we're going to be factoring things that look like this. So we'll do a few of these together, and then we'll get into examples. But we're going to be factoring things that are a combination of numbers and letters. So let's do it. So for 15, the factors here would be 1, 3, 5, 15. And let me do it here, 15x cubed. And the x's would be x squared, x cubed. For the 9x squared, looks like we'd have 1, 3, 9, and we'd have an x and an x squared. And for the 12x, we'd have a 1, 2, 3, 4, 6, 12, and we'd have an x. And now we're going to find what's the biggest one of all of these. So it looks like for the numbers, we got a 3 and a 3 and a 3. And for our x's, looks like x is the biggest. And so now we can combine this. The greatest common factor of these three monomials is 3x. So let's do these ones. I'm not going to list them all this time. What's the biggest number that can go into negative 24 and 8? Well, I know that negative 3 times 8 is negative 24. And there's an 8 in here as well. So it looks like we can pull out an 8. And of our variables, we got an xy and an xy. So xy seems to be the biggest factor that we could pull out of these two monomials. Let's look at the next one. We have a 15, we got a 10, we got a 50. By looking at it, I can see that 5 goes into there. 10 goes into 10 and 50, but 10 doesn't go into 15. So it looks like 5 is going to be the biggest number that we can pull out there. And then let's look at our variables. We've got an x squared here, but only an x here and an x here. So it looks like we can only pull out a single x. But our y's, we got a y squared, we got a y squared, and we got a y to the 4. So it looks like we can pull out a y squared. Okay, so that's the greatest common factor of these three. And now let's do a few questions. What these questions will look like, you need to factor each polynomial. So previously we were used to kind of doing the reverse of this, and I'll show you when we check our answers. But now we're kind of doing an opposite. So we're trying to find what's the greatest common factor between 5x and 35. Looks like, 5 can go into each of these. 5 can go into 5, and 5 can go into 35. 35 doesn't have an x with it, so we can't pull out an x. So we're going to divide each of these terms by our greatest common factor. So we're going to divide each by 5. 5 will become our common factor. And if we do 5x divided by 5, we're left with an x plus 35 divided by 5 is 7. And this maybe looks like what we've been used to. We can, check our answer if you want by distributing it back in and seeing, did we do this correctly? 5 times x is 5x, and 5 times 7 is 35. And you can see, oh, indeed, we did do this correctly. We got where we started from. So we can check our answer and say, oh, yes, we did this correctly. So there you go. Let's look at the next one. We want to see what's the greatest common factor. If we look at the numbers, it looks like, 3 can go into 3. 3 can go into 9, and 3 can go into 6. So I'd say that's our greatest common factor. And our first one has an X, our second one has an X, and our third one has an X as well. First one doesn't have a Y, it doesn't have a Z, so it looks like 3X is the greatest factor that we can draw out of each of these. And we're going to divide each of these terms by 3X. So 3X is our factor. 3X divided by 3X is 1. Plus 9 divided by 3 is 3. Remembering if you are dividing the same base, we can get rid of those. We have, remember, a secret little 1 there, so that's going to cancel that out. We're left with 3y plus 6 divided by 3 is 2. Those x's will cancel each other out, and we're left with that z. And then you can check if you want. You can say, did we do this correctly? We can check our answer. We can redistribute this back inside. And let's see what we get. I'll do it in green. So 3x times 1 is just 3x. 3x times 3y, it gives us 9xy. And 3x times 2z would give us 6xz. And indeed, that's the same as our original question. So you can tell, oh yes, I've done it correctly. Let's do the last one together. I won't check this one. Looks like we have a 3 can go into 3, 3 can go into -9, and 3 can go into 27. So I think that's going to be our best. Then we have a c cubed, we've got a c squared, but then we have a d. So it looks like we can only pull out a 3 out of each of these. So let's do it. 3 becomes our factor. If we do 3 divided by 3, we're left with c cubed. -9 divided by 3 is -3c squared. And -27 divided by 3 is -9d squared. And I won't check that. You can check it if you'd like. It's always available there if you want to do it. But let's just do a couple more examples. There are a few questions like this, so I wanted to do a few of these with you. And I think these are, pretty straightforward. They've already kind of done the factoring for us. They've already found, state the missing factor. So it's going to end up looking something like this. They've already given us this greatest common factor out front. So we just need to divide each of the terms by that greatest common factor that they've already given us. Very kind of them. So we already have that 5w. 15 divided by 5 is going to give us 3. We're going to get rid of one of those w's. We're left with 3w. And -5 divided by 5 is a -1. The w divided by the w cancels each other out. So we're left with 3w subtract 1. And you can check, if you would like, you can check, is it true that 5w, if we distribute this inside, we get the same? You can check. We can check this way, see what we get. 5w times 3w gives us 15w squared, and 5w times -1 is -5w, and indeed that's the same as what we started with. Okay, let's do the next one. Again, so kind of them. They've already given us the greatest common factor. So let's divide each of these terms by that greatest common factor, 10y and 10y. Okay, so 10 divided by 10 is just 1. We can, get rid of that. This y is going to take care of one of those y's. So it looks like we're left with an x squared and a y. -50 divided by 10 is going to give us -5. One of these y's can cancel with that y, and it looks like we're left with a -5x. We can check this answer if we would like. So we can distribute 10y x squared y, subtract 5x, and let's distribute inside and see if we get with what see if we get where we started. So 10 y times x squared. Y would give us 10x squared y squared. Okay, I got cut off. I was distributing. So here we go. 10x squared y squared. Let's distribute the next part. 10y times negative 5x. 10 times negative 5 is negative 50. And then we've got an x and a y. And that is indeed where we started. So good job. So that one's good. That one's good. This last one, just kind of in the reverse order. So you have to find the factor, but they've already kind of taken it out for you. And I want to point out this is a very good hint right here that it's +1. So you can imagine this thing divided by something is going to equal 1. Well, what do we know? That anything divided by itself is going to be 1. So I think there's a pretty good chance that the answer is going to be 5xy. So I think that they've kind of, shown their hand here, so to speak. But let's check, just in case. Let's check just in case. Does it seem like the greatest common factor amongst these is going to be 5xy? Well, then you can see the greatest number that goes into 35, 15, and 5 is indeed 5. Okay, and here we've got an x and a y. This has an x and a y, and this has an x and a y. So I would say yes, it does seem like that is our greatest common factor here. So I've put that in the line. You can distribute if you would like to check. So is it true that if we distribute this amongst that, we would get where we started? 5xy times 7 gives us 35 x squared y plus 5 times 3 is 15. Xy times xy gives us an x squared y squared. And 5xy times 1 gives us 5xy. So indeed, we did end up where we started, and you can feel confident that you got that one correct. Okay, I'll let you know what textbook questions I'd like you to do.